everyone. Welcome to our podcast. Today's topic is trust management in cloud computing. Today's guest is Shruti Shinde. Welcome to the Shruti.
Thank you so much.
Let's begin the questions. What do we actually mean where we talk about trust management in the cloud?
Okay, it's a great question. Trust management in cloud computing refers to the set of policies, framework, and technical mechanisms that determine who and what is allowed to access resources in the cloud environment and under what condition. It's not just about the password, it's about the establishment confidence between all the parties involved in the cloud provider, the businesses using cloud and end users.
So the next question is what make the cloud context especially tricky?
Okay, the cloud fundamentally changes the threat surface in the traditional on-prem setup. Your data lives behind your own firewall on your own hardware. You control the physical layer the moment you move to the cloud, you are handling the physical infrastructure over the third party, AWS, Azure, Google Cloud, whoever. That immediately raises the question how much you trust them, and then beyond the provider. How do you manage trust between thousands of microservices, APIs, and the users who might be logging in from anywhere in the world?
So the next question is you had millions of the people working from home, successing computing systems remotely.
Okay, that uh, dramatically the pandemic was essentially a massive, unplanned environment in distributed work organization that had mature cloud trust frameworks, adapted pretty well. Those that hadn't invested in things like zero trust architecture or identify the access management, they really struggled. We saw the spike in breaches during that period, precisely because traditional perimeter based security, the idea that everyone inside the office never trusted.
So the next question is that's become kind of buzzword in the industry. You can break down.
Okay, absolutely. Zero trust is built on a simple but radical idea: never trust, always verify. In a zero trust model, no user or device or service is automatically trusted. Even if they are inside the corporate network, every access request is authenticated, authorized, and continuously validated. Think of it like this: instead of castle with a moat, where once you are inside, you are free to roam. Zero trust is more like the high security buildings where every door requires its own badge, like scan and access scan lodged in every step.
So it shifted from a location-based trust model to an identifier-based one.
Exactly, your location, whether you are in the office or in any other places, becomes largely irrelevant. What matters is who are and what device you are using, and whether your behavior matches expected patterns. That's the foundation of modern cloud trust management.
So the next question is what an organization is building out a trust management strategy for the cloud. What are the key pillars they need to focus on?
Okay, I would say that the five main pillars, like first is identify and access management. This is one of the cornerstone. You need to know who is accessing your systems, user applications and devices, and enforce least privilege access, meaning everyone gets only the permissions they actually need, nothing more.
Right, the principle of the least privilege.
Exactly, the second pillar is data encryption. Both in the transit and at the rest, all data moving between users and the cloud or stored in the cloud servers should be encrypted, and this ensures that even if someone intercepts it or breaches a system, the data is unreadable without the right description keys.
And who manage those keys, the cloud provider or the customer?
That's actually really important point, and it's trust decision in itself. Many cloud providers offer a model called bring your own key, or where the customer controls the encryption keys. This gives businesses much more confidence even the cloud provider can't access their rooms data. Third pillar of continuous monitoring and auditing. You need real-time visibility into what's the violation. Tools like security information and event management system aggregate logs and flag anomalies.
What about the fourth and fifth pillars?
Okay, fourth is the compliance and governance. Aligning your cloud practices and regulatory frameworks like GDPR in Europe and healthcare in US and India's DPDP Act. These aren't just legal obligations. They are just trust signals. When a cloud vendor can demonstrate compliance, these standards, it builds confidence with customers. And fifth pillar is the third party risk management. Most cloud environments aren't just one provider. You have got dozens of SaaS applications, APIs, and integrations. Each one is a potential trust risk. Organization need a vet every third party tool they bring into the cloud ecosystem.
That's a lot to manage. Are there established framework that help organizations structure all of this?
Definitely, the NIST cybersecurity framework is widely used. It provides a structured approach to managing cybersecurity risk across identifying, protect, and defend. And then this respond and recover. The cloud deployment models, and then the zero trust, especially NIST special publication like 800-207 is the definite guide. These framework give organization a roadmap so they are not reinventing the wheel.
So the next question is Capital One, Microsoft Exchange various healthcare data leaks. What pattern do you see in organizations that get wrong?
Okay, these are the few recurring mistakes. The most common one is I misconfigured storage buckets, like simple setting errors that expose sensitive data into public internet. It sounds almost embarrassing, but it's responsible for the enormous number of breaches. In 2019, the Capital One breach was partly due to the misconfigured web application firewall. These aren't exotic nation-state level attacks, they are basics gone wrong.
So something the enemy is the complexity and human error more than the sophisticated hacking.
Overwhelming is the cloud gives you incredibly powerful tools, but those tools come with complexity. Many organizations move fast to the cloud, especially during digital transformation pushes, and they don't invest adequately in training their teams or reviewing configuration. Shadow IT is another big challenge. Employees spinning up their own cloud services outside of IT's visibility because it's convenient. So suddenly, you have sensitive company data sitting a personal Dropbox account or a free tier cloud database.
So the next question is how much should organization trust the cloud provider themselves? I know AWS and Azure publish compliance and certification, but how meaningful are those?
Okay, this is really an area. Certification like SOC, ISO, and FedRAMP are meaningful. They represent rigors and third-party audits, but they are the baseline, not guarantee. The shared responsibility model is crucial to understand here. Cloud providers secure the infrastructure, the physical data centers, the hypervisor layer, and the network, but you, as the customer, are responsible for everything you put onto the top of that your data, your application, and you access control. A lots of organizations mistakenly assume the cloud provider is handling everything, and that's where gaps appear.
That's something I think a lot of small businesses, especially or don't fully grasp?
Absolutely. I always use the analogy that renting a cloud server is like renting an apartment. The landlord maintains the building structure, the elevators, and the lobby security. But what happens inside your apartment? Whether you lock your door, whether you have a smoke detector, that's on you. But the cloud provider isn't going to notice if you left database publicly accessible.
So the next question is what emerging technology or trends are reshaping cloud trust management? I'm thinking thing like AI, blockchains, quantum computing.
Lots of exciting and concerning deployments all at once. Let's start with AI. On the defensive side, AI and machine learning is a revaluing threat decision systems can now learn and normal looks like for a given use or application that flag deviation in real time. Catching things that rule based on would miss, but AI is also double-edged sword. Attackers are using AI to craft more convincing phishing attacks, to automate vulnerability scanning, and to generate deep fake based social engineering attacks. So trust is identified verification is being challenged like never before.
So the next question is what absolute block there have been a lot of hype around using it for security and trust.
Blockchain has genuine promise in specific use cases, particularly the audit trails and identify management. And immutable decentralized ledger of access events is very appealing for the overhead. Make it impractical for most general cloud security uses case right now. I would say it's promising nice tool, not a replacement for a traditional trust mechanism.
And quantum computing, that's the one that keeps security peoples up at right.
Okay, it really is. Most of the encryption underpinning cloud trust today, it is an RSA elliptic curve cryptography, relies on mathematical problems that are computationally infeasible for classical computers. Quantum computers, once sufficiently powerful, but could break these in hours and even in minutes. NIST has been working on post-quantum cryptographic standards, and forward-thinking organizations are already beginning to plan their migration. The the threats isn't immediate. Where are probably still years away from the cryptography relevant quantum computers, but the data being encrypted today could have could have been harvested now and decrypted later. That's harvest now and decrypt later threat.
So what does the good posture look like for organizations preparing for a post-quantum world?
Okay, crypto alligative building systems that can swap out cryptographic algorithm without a complete overhaul. Organizations should audit their dependencies, know that the encryption algorithms they are using everywhere, and start testing this post quantum candidates. It's not something you can do overnight, which is why starting now matters.
So next question is I want to end with something actionable. If a business leaders or a developer is listening right now and they want to improve their cloud trust postures, where do they start?
Okay, three things I would say immediately. First, know your shared responsibility boundary. Read your data providers documentation and understand exactly what they handle and what your own. That's one insight prevents an on enormous number of incidents. And then second is audit your identities. Do a full review of who has the access of what the or a cloud environment. You will almost certainly find orphaned accounts from the former employees, overly passive roles, and server accounts with far more access than they need to clean up that up.
And the third,
and enable multi-factor authentication everywhere. No exceptions. It's one of the highest impact, lowest cost controls you can implement. Studies consistently show AMFA blocks the vast majority of the automated credential attacks. It's not glamorous, but it works. And if you want to go further from there, invest this in security training for your team and then implement a cloud security posture management to the tool that catch misconfiguration automatically and start building toward a zero trust framework.
so the next question is what are the key advantages of a trust management system in the cloud?
Okay, there are several advantages. Like first is enhanced security. Trust management ensures that the only authenticated and authorized entities get access to the cloud resources. It prevents unauthorized access, which is the root of the most breaches. And the second one is it enables dynamic and fine-grained access control. Instead of binary allow or deny, modern trust frameworks evaluate context, time of access, location, device health, and user behavior, and adjust the privileges dynamically. This is called attribute-based access control.
That's quite sophisticated. What else?
Okay, third one is scalability. Cloud computing are massive, millions of users, hundreds of services. Trust management automates and scales the policy enforcement, so you need a security team manually approving every access resource. Okay, then fourth one is it builds user and business confidence. When clients know a cloud provider has a strong trust framework with audit, certification, and transparent policies, they are more confident migrating sensitive workloads to the cloud. And finally, it's compliance. Regulations like GDPR, HIPAA, and ISO require organization to demonstrate controlled access and data protection. A trust management system makes compliance reporting much easier.
Uh, so second powerful, but clearly there are the challenges. What are the main limitations of the trust management?
And the main limitations, the first one is complexity of multi-cloud environments. Most enterprises uses AWS, Azure, and Cloud Google Cloud, sometimes all three simultaneously. Establishing consistent trust policies across these platforms is incredibly difficult because each has its own identity and access model.
So fragmentation is a problem.
Exactly. Then there is insider threat problem. Trust management often does a great job of keeping outsiders out. But what about the trust employee with with the credentials who acts best? That's harder to detect and requires behavioral analytics layered on the top and trust systems. And the third one is performance overhead. Evaluating trust in real time, checking certificates, running policy engines, validating tokens, adds latency for high frequency application like real time trading. This can be significant bottleneck. And the fourth one is trust transitive. If the service A trust service B and service B trust service C, does A automatically trust service C? Not necessary, but many times accidentally allow this change, creating unintended access paths. And finally, the lack of standardization. There's no universal trust protocol for the cloud. Different organizations implement it differently, making interoperability a genuine challenge, especially in B2B cloud integrations.
So the next question is the what are the real world application of the trust management in the cloud?
Okay, the main real world application of trust management, the most prominent one right now is zero trust architecture. You have probably heard the phrase never trust, always verify. That's the zero trust model. Organization like Google implemented it internally. They call it Beyond Hop, and now it's gold standard and enterprise cloud security.
What about healthcare and finance, the sector that handle the really sensitive data?
These are the prime example. In healthcare, trust management controls who can access patient data records stored in the cloud. Doctors, nurses, billing teams, and all different privilege levels. Systems like cloud-based EHRs use trust framework to meet HIPAA requirements while enabling remote access for telehealth. In banking and finance, trust management governs APIs, access between banks, payment processors, and fintech apps. When your payment apps talk your bank clouds, trust tokens and certificates ensure that every transaction is from legitimate resource.
Thank you, Shruti. This has been such an insightful conversation.
It's my pleasure.
Thank you to everyone listening, and thank you so much for joining us on Cloud Talk. Thank you so much.